Good evening, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will discuss the component multivariate econometric modeling. So, in last couple of lectures we have discussed the entire structure of econometric modeling, that to bivariate analysis and trivariate analysis. In fact, trivariate itself is the entry point to multivariate, but for simplicity or you can say understanding point of view, so we have classified into three different setup. One is the bivariate setup, trivariate setup and multivariate setup. So, we are just entering one after another complex problems, but the starting point of econometric modeling is with respect to two variables. If the system consists of two variables, then we can proceed for analysis or you can go for fitting econometric models. So, that is how so the starting point of econometric modeling involves two variables. So, one is dependent and another is independent. So, now the process will be very complicated and means in fact more complex if you proceed or if you enter one after or if you add one after another variable in this particular systems. Okay. So, like this. Okay. So, the starting point of the case is like one is y here, another is x1 here. So, we like to know what is the influence of y and x1. So, this particular structure is called as a bivariate econometric modeling. Okay. So, now in the case of trivariate, so we have one dependent variable y and we have two independent variables x1 and x2. So, like y here and we have x1 and we have x2. Okay. So, we like to know how x1 and x2 has integrated in the case of y. This is case of trivariate modeling. All right. So, this is the case of trivariate modeling. So, here there are two independent variables and we like to know what is the influence of two independent variables to dependent variables. Okay. You see here, when we move from bivariate to trivariate, then in fact the variable size number of variable size is very high. In the same times the complexity of this modeling is also substantially increased or you can say substantially very high. For instance, here very interesting point is that we can able to track what is the exact relationship between x1 and x2, but so far as econometric modeling is concerned, means best fitted model is concerned. So, particularly in the case of trivariate model and onwards, like trivariate, then if you proceed to multivariate, then in that case the problem is that the relationship between these independent variables, what we usually call is a multicollinearity problem. Okay. So, you see here, so here there is no such problem. In the case of bivariate model, the problem means the structure itself is a very simple one, where the complexity is almost all very negligible or at the low level, but the complexity or the game is more interesting when we will move to trivariate or multivariate. I will detail highlight here. So, what is the basic problems or setup when we move from bivariate to trivariate. So, the journey starts from bivariate, then ultimately we have to move to trivariate. Okay. So, then I will just before moving to the trivariate econometric multivariate econometric modeling. So, I will little bit highlight here the basic setup of this means particular problem. So, one of the standard problem here is the multicollinearity issue. So, what is all about this multicollinearity issue? Multicollinearity issue means the existence of linear relationship among the regressors. So, what we call it a independent variables, independence variable in this particular setup. So, now in this particular structure, this model accuracy is not okay, or means the model cannot be best fitted. It may be close to best fitted, but I will give you another examples here, so that you can get to know how is the model fitted. So, let us say I will have a structure like this y, this is y and this is x1. So, I will create another variables here x2. This particular this is one problem and this is another problem. But if you compare these two, this is trivariate model and this is another trivariate models, but now between these two, so this is considered as the best models, because this is considered as the best model, because there may be some other problems, but by external outlook you can make a guess that this problem is means probably it will be best fitted. The reason is that because the additional problem which we will receive from the trivariate model is the multicollinearity issue, which is not clearly visible here. So, the moment if you put in a set form, So since there is no intersection between x1 and x2, so obviously we are making a guess. It's not a question of guess. The moment if the sample information says no close, means no connection, then obviously by default itself they are totally independent. But they should not be completely independent to y. If there is completely independent to y, then there is no point to put it in any econometric models. So that means, so x1 has an influence on y, x2 must have an influence on y, but in the same time x1 should not have any connection between x1 should not have any connection. So if there is any connection, then obviously the problem will be more interesting, or you can say more complexity. So for instance, if by any chance if there is such a relationship between x1 and x2, then ultimately ultimately the complexity will start increasing. For instance, I'll take another issue here. So this is y, this is y, this is x1, okay, this is y, this is x1, and this is x2, okay. So this is another trivariate model here. So now you see here, this is one different problem, this is another problem, this is altogether another problem. So now if you compare all the, forget about this bivariate analysis now, because we are already moved to trivariate, because a multivariate has a little bit connection to the trivariate, and more or less trivariate and multivariate are in the same groups, okay. So it is one structures. So now in this particular setup, so if this is the case, then by look we can say that it is a best fitted model, and that model can be considered as the best fitted. Obviously we have to go for estimation process, then reliability check, etc., etc. But in the meantime, if you will find this setup is like this, case 1 and case 3, then it is little bit negative side of the reliability, or the negative side of the econometric models. And again if you compare 1 and 3, then obviously 3 is more complicated, and this problem is more dangerous, because here the association between x1 and x2 is too much high, okay. So as a result, by default it will means before going for estimations, if you will go for cross checking of the all this data and information, then obviously you have to find out solution for that, so that before facing problem you have to cure it. Otherwise, if you go with this type of structures, then I am very sure one point of time your reliability will get affected. So what you have to do, so before you going for estimations, then obviously you have to clarify all these details and process, so that it cannot be problem at all. So sometimes it's not possible altogether, because if the sample observations are not straightforward and too much high, then that times it is means it is very problematic. So anyway, by any chance if you can make a guess, then obviously you have to find out its solution before you enter into the estimation and reliability checking. Otherwise it means it is altogether step by step process, and every step you have to be very careful about all these problems or complexity, so that when you will go for estimation and reliability, you may not face this type of problem further, because the moment you enter into the estimation and reliability checking, so it is you have already spent lots of time, effort, etc. So it is because though it is a continuous process, still it will create unnecessary headache for you to go for this checking, etc. So it's better to find out its solutions. So similarly, I will take another case here. So this is y, this is x1, and this is x1. This is in fact more dangerous, because here the degree of association between these two variables is, you can say, substantially very high. So that's why you have to be very careful about it. In this, if in case you are facing a problems like this, means this is how we are making a guess with respect to information, because we have not entered anything about estimation, but plotting all these points with respect to x1 and x2. So we are checking how they are, whether there is a association. You see, if you have a y information and x information, let us say some y informations are there with respect to time or with respect to cross-sectional unity, then you may just apply the set theory and you find out the intersections, okay. If y x1 intersection cannot 0, then that will be fitted. If y x2 intersection is not 0, then it is fitted. But the essential requirement to fit that particular model y with respect to x1 and x2 is that, so the intersection between x1 and x2 should be 0. Okay, there should not be equal to any common element. If there is a such common element, then there is a problem of multi-coordinate, and that is one of the obstacles of econometric modeling. So you have to bring a particular system, so where y and x1 has a connection, y x2 has a connection, but in the same times x1 and x2 has no connection. But in the real world problems, it is very difficult to find out a situation where y x1 has a linkage, y x2 has a linkage, and in the same times x1 and x2 has no linkage. So that is particularly for trivariate econometric modeling, and the complexity is more interesting when we will go for multivariate modeling. So now in the case of trivariate, so it's very difficult because most of the variables are very interdependent each others. That dependency depends upon means it depends upon the degree. So if the degree is very low, then obviously obviously the model accuracy will be very high, but the degree of collinearity is drastically high, then the model accuracy will be very low. It's inverse relationship to inversely related to each other. So that means model accuracy depends upon the degree of linearity among the regressors. So if the degree of linearity among the regressor is very high, then obviously model accuracy will be very low. But if model accuracy is very high, when by default we are guessing, or we can observe that there is a substantial chance that the degree of association between x1 and x2 will be substantially low. This is the basic starting point of this trivariate modeling. So means what my intention is here that, so I like to highlight when we move from basic to complex, that means in this particular structures, if you move from bivariate to trivariate and trivariate to multivariate, what type of problems you usually face and what sorts of advantage and disadvantage. Obviously so far as a overall model fitness is concerned, then the multivariate model is always very strong enough, or you can say very beautiful to justify something. But in the same times, there are some additional problems, some complexity are there that you have to taken care of very properly. So if you could not take that type of problems, then obviously it will affect the model accuracy, or you can say model reliability. So you must be very careful about all these problems. So with this basic, in fact there are certain other problem also which is not typically visible in the case of, you can say in case of trivariate models, but it can be visible in the case of multivariate model. So we will see how this particular problem can be more complicated, more complex once we move to the, you can say, multivariate process or multivariate modeling. But you remember one thing, if you are very comfortable with the bivariate structure, then you can able to you also feel enjoyment in the bivariate trivariate structure and multivariate structure, because the structure is more or less same. Only the additional part is just we are adding one after another variable to the system. So far as a calculation or formulation is concerned, it is a little bit complicated, and for different problems, or you can say different degree of involvement, so we have to use mathematics accordingly. Okay, for instance, in the multivariate models, so means once you have a bivariate setup, then it is very easy to handle the situation. If trivariate, it is still easy to handle the particular situation, but if it is a multivariate consists of, you can say, 10 variables or 20 variables, so it's very difficult to handle together, and that in that particular context, by simple mathematics, it cannot be possible to you can say solve this particular problem, particularly if it is in the classroom classwork, but still it can be able to manage, provided you must have a strong mathematical knowledge. For instance, if means particularly mathematical tool matrix is very useful for multivariate technique. Until unless you have a complete information of matrix knowledge, then it is very difficult to solve multivariate problems in a particular classrooms. So yes, of course, when we will go for research oriented problems or project oriented work, then that times, in fact, we have to handle in a software, statistical software, proper statistical softwares. So that times just you have to know the themes and know the structures, know the setup, and you can say interpretation, all these, or you must have complete knowledge about this modeling, then you have to operate properly that softwares, that's all. But just you have to this theme is just you have to interpret properly with respect to the obtained result and its interpretation. But when you are in the class, you have to be very careful and you should be little bit smart enough how you have to handle the situation with a quick time, without having the use of statistical software or without use of, you can say, of course, some of our lectures we allow Excel sheet to handle these situations, but Excel sheet is just like a calculator, so it will help in middle levels only. It will not give you the final. The moment you will go for software use, then it will give you directly, it will give you the final result. So the intermediate process, it's very difficult to have through softwares. Okay, of course, if you use the programming, then if you go stepwise, then obviously you can have this information. But this is more or less complicated. Ultimately, we have to justify something else. Okay, so our point is not to make a beautiness in programming or make beautiness in softwares or make beautiness in mathematical formulation, etc. Our structure is to fit the estimated models, and that should be considered as the best. That is how we are doing all things. These are the helpful tools through which we can have the results very quickly, so that we can manage the themes in a less time. So that is how this means these are the basic fundamental issue or basic information before we proceed to multivariate analysis. So now first thing is, what is all about multivariate analysis? Okay, let me highlight here. So multivariate analysis, multivariate modeling, basically here the system is like this, means I am just graphically highlighting the issue. So here y is considered as a dependent variables, and we have x1, and we means I am now moving at a good structural level, so that the complexity automatically removed. But let us first try in a simple structured way, then we will go for complexity. Okay, so what is simple structured way? The simple structured way is, here the game boundary is means more than k more than 3, because we are all together multivariate. That means y is 1 obviously, then obviously means in the other sides k must be greater than 2. Okay, so what in the case of just like in the case of bivariate model, what we receive, forget about n, but k is important here. So k is equal to 2 here. So in the case of trivariate models, so n is okay, because k has a lots of integration with n, because the reason is that your model accuracy or model reliability depends upon your sample size and number of involvement. For instance, suppose you have a model, you have a model consists of 20 variables, and you have another models with 2 variables. Okay, that means it is a bivariate and it is a multivariate, but here k equal to 2 and here k equal to 20. Sorry, 19, keeping in means in addition to the dependent variables. Anyway, if you add together, if it is k here means k is considered as 2, then obviously here k is considered as a 20. So now you see here, with 20 sample observation, you can go for estimation, but if with 20 samples and 20 variables, you cannot go for this estimation. And when you will add one after another variable, then obviously you make a look that, or you must be in a position to increase sample size accordingly. So the moment you will add one after another variable, the same sample cannot be used accordingly. So that should be, you can say, for instance, if it is 20 samples and you are going bivariate to trivariate, it is not a problem. Or if you add another variable, it is not a problem. But if you add 15 more variable at a stage, then obviously it will be very complex, and by default you will get model inaccuracy. So you will not get a best fitted model. So that's why the n and k has lots of integration, because it is one of the checkpoint through which you can get to know whether the estimated model, or the way we will estimate the model, it will be most reliable, and it can be best fitted, and it can be used for forecasting. So these are all different cross checking methods through which you can make a judgment before you go for estimation or reliability checking. If all these cross checking is something negative, or you can say other way around, then obviously you have to clear, or you have to first erase all these problems, then before you going to with the estimation and you can say reliability checking. So now, so what we have observed here, first observation is see the relationship between independent variables is more complex when you will go to multivariate model, and in the same times the relationship between n and k has to be taken care properly. That is, these two things are very important here in this case of multivariate setting. Okay, so now in the case of trivariate here, k equal to 3. Okay, so now when we will go for multivariate models, so in fact multivariate models with respect to how many variables, that is very important. We can represent here. So let's say k equal to say 10. So that means it is this system is consist of multivariate where number of variables equal to 10 only. Okay, so 10 means one dependent and another 9 other independent variables. So now this particular problem is more interesting, more structures so far as a multivariate is concerned. So now you let us assume that for very simplicity, so what we can do, we will start with say 4 variables together. So that 4 variables mean it can be considered as also multivariate. Okay, so let's see, if we will go for 4 variables with this very simple structure, then we will assume that whatever independence variables in our system we have, so these should not have any correlation, means they should not be related each other again. So that means we have another variable say x2, and we have another variable say x3, and we have another variable say x5. So now here I don't know, means we cannot right now, we need not require what is the n structure. Of course it should be obviously substantially greater than to k. So but here k is how much, x1 x2 x3, this is x1 x2 x3, this should be x4, let's say. Okay, this is x4. So now, so altogether there are 5 variables here, there are 5 variables. So that means the essential condition is that n should be substantially greater than to k. So that means your n should be obviously greater than, at least greater than, even if it is equal to 5, the result cannot be, the model cannot be best fitted, or the accuracy itself. Sometimes if you put in softwares, it may not operate properly, it will give you message that insufficient information. So this is how you have to be very careful. Okay, so in the meantime, so what you have to do, so you have to take care of this particular problem. This is very serious issue before you going to multivariate models. All right, so now the way I have here structured the particular problem is that, so y is here, so that means y is a function of here x1 x2 x3 and x4. So this is how the mathematical formulation of this particular problem. Okay, because when this econometric modeling has a lots of beauty. So one beauty is you must have a very theoretical knowledge, and the theory must be very perfect, and it should be very interesting, or it must be very challenging. Then through the theory you have to build a mathematical models. Okay, so this mathematical model has also beauty, because there are many ways you can formulate the mathematical models. So then once you will get a proper mathematical model, then that can be transferred into proper statistical models. Then our starting point will be means that is the starting point for our econometric modeling. That means before we start any econometric process or econometric modeling, so you have to do lots of homeworks with respect to theory, exact problem, objectives, and of course there is also hypothesis, which you have to be fixed, means we have to fix before going for this model fitting. Okay, sometimes this is altogether in research you have to do all these assignments. If it is a small classroom problem, that is different task, but the actual issue is in econometric model is that it should be substantially attached with a particular theory and problems, objectives, and hypothesis. So these are all your home assignments you have to do before this econometric fitting of econometric modeling. So the moment you have, then you have to do all cross checking first, then you have to proceed further. So in this particular setup, so what we have observed, so this is the mathematical formulation of the model. But in this particular context, if we transfer this mathematical form of the model to statistical form of the model, then the formulation will be like this: x1 x2, x3, x4s, then u. Okay, so this is the statistical form of the model. This is statistical model, this is mathematical model. So of course this mathematical model, this is in implicit format, can be represented in many ways. This is also implicit format, can be represented in many ways. For instance, it can be they may be linearly related, they may be non-linearly related. Again, non-linearity, there are various shapes, like it may be the logarithmic in nature, it may be exponential in nature. So like this, it may be some kind of powers functions. So there are certain rules and regulation through which you have to observe all these details. Okay, so now once you have a statistical form of the model, so now if you integrate with these statistical models, but typically this econometric issues, then obviously if your information is plotting of information is coming like this, then obviously so that means you the structure is like this. You see here, the structure is, in this particular case, we have y consists of y1, y2, then you can say yn. Okay, so this is how the structure is all about. So these are all sample information. Similarly, we have for different variables, independent variables. So we will take x1. X1 is nothing but x11, x12, then it is nothing but x1n. Okay, x1n. So similarly, for x2, the picture is x21, x22, x2n. Okay, x2n. Then x3 consists of x31, x32, then x3n. Okay, then we have to move to x4, x41, x42. Okay, then x4n. So for k number of variables, so it will extend to k. But this particular formulation, so we have for independent variables and one dependent variable. So the sample information is you can set the sample information like this way. In fact, these are all theoretical setup. There may be some quantity figure in all these details. Okay, so what you have to do for the for when this model will be like this, y and x1, x2, x3, x4 like this. So these means there is no common elements in between. So that means there is no connection between this and this, there is no connection between this and this, and there is no connection between this and this. Means these are all no correlation. Again, the complexity will start with the x1 and x3, and the complexity will start with the x1 and x4, then in fact x2 to x4 again. So these are the possible way you have to find out the linear relationship among the regressors, and these are all essential before you going for, you can say, before you going for estimation of this particular multivariate econometric model. So since the means by graph we are getting that there is no such intersection. So obviously this correlations, there is no correlation between all these items. So we will highlight how it can be structured altogether. For instance, for x1, x2, so what is this collinearity? We can get the correlation coefficient x1, x12. So obviously, if your structure is like this, then obviously if you correlate x1 and x2, then correlation x1 and x2 means not most probably, means obviously it will be equal to 0, because there is no common point here. Similarly, rx1 3 will also equal to 0. Then x14 is also equal to 0. Then x2, rx12, x14, then rx2. Okay, x23 is equal to also 0. Then rx24 is also equal to 0. These are the possible ways you have to justify x1 2 3 x13 is left here. Okay, x1 is 3, this is x1 x2, this is x1 x2, this is x1 x4, this is x1 x3, then x1 x4, this is x1 x4, then x1 x3, this is x1 2 3. So there is x1 3 is already here. Okay, so x1, x2, x3, then x2, x4. Okay, x2, x4. So these are the possible cases. 1, 2, 3, 4, 5. Okay, then another is the x14. x14 is there. x14, x24. Okay, x24. So x24 is equal to 0, right? So these are the possible ways we have to establish the relationships. So these are all equal to 0. Okay. So now in this particular structure, if we move for econometric modeling and its estimation and reliability checking, most of the chance means most probably you will get the best fitted models. So you know, we will now proceed to discuss the details about this econometric modeling, that to multivariate setup. So in addition to this particular problem, so we will face very interesting, very complex issues also. Let us highlight what are these complex issues. Okay. So how do we start with this particular multivariate models, and how beautiness you can apply so that the model can be very accurate or very perfect to go for the mathematical derivation, or you can say mathematical estimation. So let us proceed with that particular setup. Okay. So let us assume that the system consists of k variables. Okay. So now if the system consists of k variables, including the dependent variables, so that means k minus 1 independent variables in the particular systems. Okay. So k minus independent variable and k 1 dependent variable. So altogether the multivariate analysis has to be discussed with the k number of, that means that k, we started with this concept degrees of freedom n minus k. So that k is in fact it is unknown, but it may be k equal to 10, it may be 20, it may be 30, like this way. There are many ways it can be represented, but you know, let us we start with this k setup, then we will summarize it. Okay. So y equal to, here obviously I will write like this: y equal to summation beta 0 plus summation beta I xi I equal to 1 to k. Okay. So this is the mathematical starting point of multivariate models. So if you will make a look in this particular models, then you know, in the case of trivariate setups, so we put I equal to 1 to 2 only. Okay. I equal to 1 to 2, and in the case of, you can say, bivariate model, it is I equal to 1 to simply I equal to 1 only. Okay. Because it is nothing but beta 0 plus beta 1 x1, like this. Y equal to beta 0 plus beta 1 x1, beta 1 x1. So that is bivariate setup, bivariate model. So when I equal to 1 to 2, then obviously the structure will be y equal to beta 0 plus beta 1 x1 plus beta 2 x2. That is called as a trivariate model, which we have just now we have discussed. Okay. So the complexity will start when we will go for you know, I equal to 1 to k. So that means the system will be like this: beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Okay. Plus continue beta k and xk. Okay. So this is the mathematical generalization of multivariate models. Okay. So this is altogether mathematical form of the model. Here the model speaks that your independent variables, k number of independent variables, has an integration with y. Okay. So when we fit like this way, so there is a lots of chance that there are other variables which can influence this also y, because the moment we are putting y equal to beta 0 plus beta 1 x1 up to beta k xk, then obviously we are assuming that only k number of variables which can influence y. If we will not put anything extra and we are putting this statement, that means this particular left hand side, that means x1 to xk has a you can say 100% influence on y. But still, if you are saying 100% information, statistician does not believe or economician does not believe it. So they assume that there is some means there is a possibility of some factor which can also influence the y in this particular setup. So as a result, so it has to be investigated, or it has to be verified. So the moment the question of investigation or verification is there, so obviously your first target is to get the estimated parameters. Okay, so then accordingly you will get the estimated model. So the moment you will get the estimated model, so you have to go for the reliability, that to significance of parameter and significance of overall fitness of the model. So now the overall fitness of the model will give you signal whether the starting of this mathematical form of the model and later transferring to structural form of the model is perfectly fitted and 100% fitted like this. So the justification, that means if you will say that these are the variables which are only influencing y, then in that particular case, so we know the overall fitness depends upon R square, which is when the when all these variables has 100% influence on y, and obviously R square should be exactly equal to 1.0, because R square is a coefficient of determination which range is always 0 less than R square less than 1. Okay, so if by any chance all these variables are not sufficient to influence, or 100% in not having 100% influence on y, then obviously the R square cannot be equal to 0. So that means most of the cases R square will be less than to 1. But you remember, R square cannot be negative. R square cannot be negative because it is a square. Obviously, in fact, this capital R square, and which we have discussed long back in small R square compared to this particular capital R square. Small r is a correlation coefficient which can be negative or positive, but if you will go for square of the correlation coefficient, then obviously it will be always positive. But when you will calculate simple correlation, like the way we have describes this Rx1 Rx1 x4 like this, these are all simple correlation coefficient that can be negative, that can be positive, but that is not the issue. So in that particular case, there is a possibility negative and positive, but when we go for R square, so it cannot be negative, so it will be either 0 or 1 or in between 0 and 1. So the model accuracy or means model reliability is very high if the R square value is close to 1. Okay, if the model accuracy and model reliability is very low if the R square value is close to 0, which we have detail highlighted in the case of bivariate analysis, and in fact in the case of trivariate analysis. So in the major problem is here is that, so when we are putting a k variables in the systems, then obviously there are k number of parameters. Okay, so when R square is close to 1, then the requirement, essential requirement is that whatever parameters involved in that particular models, it should be highly statistically significant. That means all these individual parameters has to be statistically significant and at the higher level, that too at least means at 1% level. So now if R square 1 and the other situations are not okay, then obviously the model accuracy is something wrong, or is a model accuracy is somewhat low. So you have to find out the situation, otherwise R square may not be exactly equal to 1. So if there is a R square equal to 1, then obviously there is lots of danger signals. So because when R square is there and other variables, all variables are not statistically significant, then definitely it is an clue that, or it will give you clue, model itself will give you clue that there is some kind of problems either in estimations or in model formulations or the inclusion of variables or something, maybe with respect to sometimes the sample size, or also the problem integration. So many things will be coming into the picture. So but once you have the estimated model, everything can be, you can say discuss, or you can say you can make a guess. But until unless you go for this estimation and you have not this estimated model, then obviously it is very difficult to say something, or you cannot make a comment. So the in fact the model for instance for econometric model case, the game is more interesting with respect to multivariate models only. The moment you will have a multivariate model, then there are various additional problem, various interesting problems that to diagnostic check, etc. So in fact, multivariate is the starting point, one of the stage through which we have to discuss so many aspects, so many different problems under econometric modeling. So we have lots of interesting games under this econometric model. So like autocorrelation problem, heterocorrelation problem, serial correlation problems, then dummy variable modeling. In fact, dummy can be also applied in the bivariate structure, then structural equation modeling and panel data modeling. So these are all interest, means what I want to say that in all these components and structures are more interesting once you handle or once we discuss this with a multivariate setup. But if the setup is very limited or in a bivariate, then obviously these discussion have a less accuracy and less reliable. Even if in the case of bivariate structures, if you get a models where all these parameters are highly statistically significant and R-square is highly statistically significant, even R-square equal to 1 and all the all the parameters are or all the variables have 1% level of significance, still there is lots of confusion. So it is also in fact more dangerous. If you say for a bivariate setup, if you are getting R-square 1 and all variables are highly significant, by default it will give you wrong signals, and that model may not be fitted for this, may not be considered for policy use, or you can say forecasting. Because but on the other side, if you have a model, multivariate models where you will get a few variables statistically significant and R-square is less than to 1, that model can be considered as the best and can be used for forecasting and policy use. But in the reverse case, where R-square is 1 and all parameters are statistically significant, and your game boundary is just limited to 2 variables y and x, that is more and more, you can say, a wrong way to go for forecasting and policy use. So one of the interesting criteria or interesting trick of forecasting and policy is that you have to fit or you have to use these estimated models, provided it should be in a multivariate setup or multivariate setting. Because for a particular once you are fitting prepared to fit a models y with respect to certain variables, then y must have some name, okay, because without a theory, without proper naming, then econometric itself is meaningless, okay, because it's not just statistics or mathematics, it is the application of statistics and mathematics to some kind of theory and problems. So that means the root is something different. The root is you have to find out the exact statistical problems, okay, so that through the problems we have to use mathematics statistics to bring a particular shape, okay. So that is how it's very interesting. So econometrics is means that we can just mention that, means you have to note that very carefully, that econometric is not only for mathematics and statistics, it is the application of mathematics statistics where you must have a sufficient evidence about the theory. That means that problem which we identify or which you like to investigate, it should be very accurate and very perfect, very authentic, so that you will enjoy this game and it will be more practical to use econometrics. Otherwise, without sufficient evidence, sufficient theory, and you just bringing information and just processing it by mathematical and statistically, there is no utility at all. So, okay, econometrics is altogether using some different problems and mathematics statistics, so that we discuss that particular problem or we represent that particular problem in a more accurate way or more authentic way. So that is how econometrics enjoys very economics has a lots of uniqueness. So you must be very careful about that, and you must remember all these things. It's not just like simple mathematics and simple statistic or simple some any subjects. But the beautiness of this particular structure in setup is that the problem can be from various angles, various areas, but we have to here analyze with the application of statistics and mathematics. That is the more interesting, beautiful of this econometric modeling. So for instance, some of the mathematical papers it is very bounded and the application is very limited, but you know the speciality of this particular econometric modeling is its features is very much infinite in nature. You can't imagine, you cannot say that where it cannot be applied. It will be applied each and every field wherever you like. When there is a question of some argument or verification or justification, that times you close your eye and just apply the econometrics, provided you must have a sound logic, sound theory, means proper theory and proper problem setup, then you can apply accordingly. You will get this process very carefully. Okay, anyway, so this is how you have to say, get the econometric multivariate econometric modeling. So now the starting point means the briefing of this multivariate econometric modeling is like this, where I equal to 1 to I equal to 1 to k, and the problem setup is like this. And if you represent in econometric models, then there should be error terms. Okay, there should be error term. Otherwise, if you just simply write beta 0 plus summation beta I xi, then it is just mathematical equation only. That means it's a mathematical model only. So, but if you add u, then obviously it is represented as a econometric models. But you know, in the bivariate setup and trivariate setups, we mention very clearly. So, this particular model can be represented in 3 different forms, like you know, with respect to your data setup, like a cross sectional samples and time series samples and you know panel data samples. So, obviously, I have not mentioned here the sampling structure here. So, whether it is a cross samples, or you can say time samples, or you can say panel data samples. So, obviously, accordingly you have to use here. So, sampling information, for instance, instead of y you have to put I, but here I have already used. So, that means you can use j also. So, that means if I can write like this, for cross sectional modeling it is you can say yj. For this particular, I am just transferring it to a cross sectional formulation. Here in this, if I will write like this way, then there is no clear cut identification. So, whether it is a cross sectional modeling, or whether it is a time series modeling, or whether it is a panel data modeling. So, again to make this in fact represents the implicit format of the models. This itself has a lots of beautiness, because something you are keeping in a hidden. So, people has to explore and have to, the moment you will put like this way, then by look you cannot make a guess what type of problem is this, or what is the estimation process. So, for that to know this one, they will read a lot, or they will go through your theory, etc. So, that is why lots of in research problems they start with like this, but inside they will mention all details, so that anybody can go through it properly and they enjoy this game. But you know, for the class point of view, or for beginners, you must be very careful about this particular formulation. And now for cross sectional modeling, the structure will be like this: yj equal to beta 0 plus beta summation beta ij and xij. No, in fact beta I only, this is xij, because the sample is with respect to variables, then uj. Okay, so this is how the formulation all about. So, similarly, when you will go for time series modeling, then j will be transferred to t. So, when you will go for panel data setting, then j will be transferred to jt. So, that similarly xit. So, this is how you have to move from samples to different sample problem, that means cross sectional to time series and time series to panel data. In fact, the panel data itself has a lots of beautiness. For instance, it will increase the sample size, but we have not discussed anything. The moment you will go for panel data modeling, then it is the integration of cross sectional observation and time series observation. So, that means there is I is not constant here. So, I itself will vary, and t is not also constant, t will vary. For instance, so suppose there are 5 different farm analysis, okay, and 5 different time periods. So, 5 into 5 different structures. So, that means it is altogether keeping t constant, where t equal to 5. I can change, j can change with respect to 5 different industry setup. Then accordingly, if you keep this constant, then t can change with respect to different time frame. So, that interesting means that type of problem is really panel data analysis. So, which we have to decide. That means if you go to set this type of structure, then there will be, you can say, different altogether it is a different ball game. So, means you will find there is a random effect, or you can say fixed effect, etc. So, these are all details means we will discuss when we will go for this panel data modeling. We have a separate lecture for that. But in the meantime, you just make a look, or you must understand the concept behind the multivariate modeling, how you have to bring the issues, how you have to bring the structures, then you have to go for this estimation process, then how you have to go for the reliability testing, etc. There is a lot of interesting games you have to find, or lots of enjoyment you will feel when you will handle the multivariate problems. You will find there are lots of additional techniques, additional tools we have to apply when we are in the multivariate setup, but which is not practically feasible in the case of bivariate setup and trivariate setup. With this basic framework, so we will stop here, because time will not permit to discuss the estimation process of this multivariate modeling. So, in the next class we will discuss details the setup of multivariate modeling. So, in the with this we will conclude this particular class. Thank you very much. Have a good day.